outcome that others can understand and make use of it for their work, right? So that's one part of the presentation. Then the other presentation we'll talk about, so what if you have not yet collected the data and you're just thinking about collecting your data, right? What special considerations do you want to put into place to make sure that the data you're going to collect will be of high quality and will be presented in ways that are interesting? And so this slide, I put up this slide, Tales by Moonlight, to really highlight the value of storytelling in research. When I was growing up, we used to have Tales by Moonlight, where the kids would literally sit outside under the moonlight and hear stories, right? That was something we looked forward to. And you have a whole industry built around stories, or whole industries. So you have Hollywood in the US, you have Nollywood, you have Bollywood. These are huge industries that have been built around mankind's love for stories. I mean, we love hearing stories, right? Because what stories do is that they steer our imagination. Stories connect into us in a way that is quite different. And so one of the myths we have in research is that for some reason data has to be boring. And there could be nothing further from the truth. It's our job as researchers to turn data into a form that is exciting. Now, that doesn't mean that you have to become subjective or you have to become dramatic, but surely there has to be a way we can really turn data pieces into things that excite and things that inform, and not just some boring stuff. So there are three things we need to address in the process of trying to tell a story with our data. Are there questions or what? Okay, so there are three things we need to there are three things we need to address when trying to tell a story with our data. We need to address things that are abstract, things that are mundane, and things that are voluminous. So when we say something is abstract, it means that the listener has nothing to which they can draw a parallel, right? If I say physics is abstract to me, it means that, geez, of all the things I know, there's nothing I can compare with this new information I'm getting that I can say, oh, okay, so what you're telling me compares, this is how it compares to what I already know, right? So it's our job as researchers to turn the abstract into familiar, things that are familiar to the reader. And the easiest way to do that is through data visualization. So that's one of the first things that we aspire to do as researchers, to convert things that are abstract into things that are familiar. The second is things that are mundane. Mundane simply in this context simply means just things that people are just tired of listening, like just tired expressions or tired data points. And then you bring your extra data point once more, and people have heard this thing for 1,000,000 times, right? So the question is, how do you present information that is familiar and a bit mundane, for lack of a better word, in ways that are fresh and novel and exciting, right? So the information itself may not necessarily be new, but how then do you convey that in a way that is new and interesting? And then thirdly, the third challenge to address is things that are voluminous. Of course, when you collect data, there are so many things you can talk about. You can talk about X and Y and Z, right? And you have tons of data, maybe hundreds of variables. But the whole point of data analysis is data reduction. We aim to reduce the dimensions of data so that we summarize the data. So there's no point, overwhelming readers with, tons of data points that we have not achieved the very point of data analysis, right? So in all of storytelling, right, these are the three things that we want to achieve. We want to address things that are abstract, we want to address things that are mundane, and we want to address things that are voluminous. So the goal is to turn ears into eyes and to stir up the imagination of our readers. Again, we have to also be mindful of our audience. Our audience is buried under, workload, right? There are so many things that are fighting for their attention. They have families, they have pets, they have emails to read, right? And so many things. And so if you are an author submitting your work to a journal, your reviewers are likely buried under other things, right, that they have to do. And so your paper is not the biggest priority to them, the same thing applies to the editor-in-chief, right, of a journal. The same thing applies to your supervisor if you're a student. You send your supervisor work to review, most likely he or she has a ton of other things to do. So the question is, how do you then present your information in ways that would really, really, motivate them to read? So that's the whole point of what we're trying to say. And so the most important thing you can do is to prepare, right? If we are likening ourselves to artists, then every artist prepares for work, right? Before they start painting, right? You get your paint together, you think of, okay, geez, what color combination do I want to create on this canvas? What do I want to paint? All right. So all of those things go into preparation of your work. And so the same thing applies to us as scientists. You don't just grab some data point and start analyzing the data. You have to sit down and think about what you want to do. And this is particularly important if you are just collecting data, right? You need to be able to think of how this data will be analyzed before it is analyzed, right? And that's why you need to have a data analysis plan so that it visualizes how all of this will take place. So preparation is so key. So again, so why is preparation and why is it important? Well, for you to collect good data, you need good questionnaires. For you to have a good questionnaire, you need to have good questions. And for you to ask good questions, you need to have the right type of questions, right? Not all questions are equal. And so that is why you need to really, really think carefully. And so for the second part of our session today, where we're talking about deliberate and intentional thoughts towards collecting data, we'll talk about the different types of questions that you could collect or you could ask in your survey, so that when you collect the data, it is done in a way that meets the objectives for which you're collecting the data. Again, keeping in mind the key objectives while we analyze data, I just want to emphasize this first part. The whole point of data analysis is data reduction, meaning that we want to simplify data, right? We want to take a data set like this and summarize it to just a line where we can say the mean value was X, or that X% reported Y. So your analysis has completely failed if your output is as complex as the original data, right? You have not reduced the data at all. You have not simplified at all. So that is the whole reason why we analyze data, to simplify things. And so it's very important to keep that in mind. And of course, the second reason is to ensure that the output from our result is indeed the truth. All right. We're going to talk more about this next week, about how do we use the results from our descriptive analysis to ensure that the methods we're using for more advanced analysis ensure that we get the truth. Because if we could summarize the whole of research or epidemiology in one sentence, it will be 3 words: truth, chance, or bias, right? That is what research is all about: truth, chance, or bias. We want the truth, but the truth isn't just hanging in space. The truth is surrounded by, like you have this image here where you have the honey is nested within honeycombs and within bees. To get that honey, you have to extract it from that honeycomb, and you have to separate it from the bees. The same thing applies to research. We want the truth, but the truth is masked by chance and it's masked by bias. So how do we uncover the truth from chance and bias? One way is to look at data visualization, right? We can look at, how the data looks, and then that tells us that, okay, geez, this clearly looks that something is wrong and we have to, make corrections for that. We'll talk more about that next week, but for today, we're just looking at just basic descriptive analysis and how we can tell a story from our data. There are 4 types of analysis. If we take all the analysis we could possibly do in this world and put them into buckets, we'll have 4 types of analysis. Again, we'll talk more about those next week. But then the first is exploratory. Exploratory analysis is more descriptive analysis of prevalence, means, correlates, and disparities. So if you have a research question like, what are the prevalence and correlates of cigarette smoking among South African adults? That is exploratory analysis. There is no clear directionality of the research question. It's like, oh, we just want to see what's happening. We don't know exactly where the road leads, but this is just descriptive. And then you have relational. Relational is now looking at the association or the relationship, as the name implies, between two things. You have an exposure and an outcome, right? So if I have a research question that says, what is the association between e-cigarette use and smoking cessation? See, that is an associational question now because I'm trying to look at the relationship between two things, whether you use e-cigarettes and the likelihood of you quitting cigarette smoking. And then you have comparative studies, right? And so those one that you have the same outcome, but you're looking at it pre or post, or you're looking at it, between, two different groups. And so those would be things like interrupted time series analysis, or if you're looking at natural experiments. And then lastly, we talk about compositional. This will include things like decomposition analysis and segmentation analysis. Again, we'll talk more about this and how the outlook of your descriptive analysis might inform the choice of what analysis to proceed with. So let's take a step back and talk about variables so that we're all on the same page. I acknowledge that we have different levels of expertise in-house or experience with data. So let's talk about what we mean by variables and the types of variables, because obviously that determines the kind of descriptive analysis and the kind of visualization that you could use your data for. So a variable is simply a column in your data set. So if this is our data set, right, each column is a variable. And so when we analyze data, we're typically analyzing at the level of variables, right? So that's what a variable is. And we just have one rule for variables in a very simple way. For you to be a variable, you must vary, right? A variable must vary. So what does that mean? It means that it must have at least two unique values, right? So here, variable A, you see all of the values in this are ones, right? So it does not vary. So if we were to use this for analysis, there will be no inherent value to that analysis because everybody has a value of 1. So that will not work for us. Column 2 is the same thing, right? It does not vary. Everybody has a value of 0. And so that is not a variable in this context because it does not vary. Now, outcome 3, now we can use this for analysis because there is variation there. Some people have value of 1, some people have a value of 0. So very importantly, for a variable to be a variable, it must first of all vary. So that's very important for us to keep in mind because you cannot do analysis or you cannot create visualization or you cannot do anything with a variable that does not vary because it is not a variable. So that's the first thing that we want to keep in mind. Now let's talk about types of variables that might exist and how that might influence the kind of analysis we talk about. The first type of variable is a continuous variable. And when we say continuous, what we mean is that if you took any 2 points for that variable, there is an infinite number of possible values between those two. So if we took, for example, 1 and 2, you see there's a continuous stream of possible numbers, infinite, between 1 and 2. That's why we call it continuous, because between 1 and 2, there is continuous stream of values. So what does that mean? If you took, for example, a height of 6 meters and a height of 7 meters, or it doesn't matter which 2 points you take. Even if you took 1.2 and 1.3, what we're saying is that there's an infinite number of values between 1.2 and 1.3 that we cannot count, right? And that's why we call it continuous. For the next type of variable, we call them count. And that means that we can count. Between 1 and 2, there is nothing in between here. This is quite different from this first one, where between 1 and 2, there is a continuous stream of values, right? That is uncountable. Here we can count because between 1 and 2, there is nothing, so it can be counted. And that's why we call it count data. Next, we have ordinal. Ordinal variables are categorical variables that have natural ordering. And so, in this case, think of, for example, first position, second position, third position, right? It's categorical, and there is inherent value in that order. And then lastly, we'll talk about nominal variables. Nominal variables have numbers or orders or categories, but the categories do not have any inherent value. So if you look at, for example, gender, if you say assign males a value of 1 or assign females a value of 2, there's no inherent value. We could easily have assigned males 2 and females 1. So it doesn't matter. Or the same thing applies to colors. If I assign red color 1 on value 1 and blue 2 and green 3, it doesn't mean that blue is superior to green. It's just random numbers, right? And so those are the different types of variables that exist. And of course, the categorization of these 4 groups we've shown here is very important because it matters the kind of analysis we can do with them. So, for example, you see continuous variables and count variables, they both have quantitative properties, right? Whereas ordinal and nominal do not have quantitative properties. So what does that mean? It means that for continuous variables and count variables, we can do things like we can take the mean. The mean value of blood pressure was so and so. We cannot take the mean of ordinal variables or nominal variables because they have no inherent quantitative properties. So right off the bat, that determines the kind of summary statistics that we can generate from those kinds of variables. So this one, we are limited to only tabulating them and saying 50% reported, 50% were in first place, or whatever, 30% were in second place of all athletes, and the remaining percentage were in third place. We cannot take the mean or the average or the standard deviations because they do not have any quantitative properties in of themselves. So continuous variables is a huge family, it's a broad family of variables that I just thought we should also understand the 2 children in that family. The 2 children in that family are ratio and intervals, right? So one way you can recognize ratio, an easy way to recognize the difference is ratio ends with 0. Well, it ends with an O, but you can think of that O as 0. So that tells you that ratio has a true 0, right? Whereas intervals, intervals does not have a true 0. So what does that mean? It means that with ratio, we can do all arithmetic calculations, plus, minus, division, and multiplication. Whereas with intervals, we can only do plus and minus because we cannot take a ratio because they don't have a true 0. So the litmus test for you to determine whether a continuous variable is a ratio versus an interval is to see whether it makes sense for us to talk about a 0 in that value or not, right? Take, for example, temperature, right? When you say 0 degrees, can you have, when we say it has 0, right? Say ratio again. When we say it has a true 0, that means that a value cannot fall below 0. 0 is is a lowest value it can fall. So can you say somebody has a height of minus 5 centimeters? That does not make any sense because with a ratio, it is capped at 0. That's the lowest you can go. So it is a true 0. With intervals, you can go. So think of it, can you have a negative value with this number? If you can, then that means it's an interval, right? If you can't, that means that it's a ratio. But they're all continuous variables. And the reason why you need to know this is, the reason why you need to know that is there a question?
Are you going to take questions as you go or later?
Let's finish the material and then we can take questions.
Okay.
And so again, the reason why you need to know the difference between ratio and intervals is because that affects the kind of analysis you can do with them. So remember, we're saying that the session today is focused on descriptive analysis, right? Which is all about how do we summarize the data? Well, like we said, with interval variables, you can only do plus and minus operations. So there you have it. That already influences the kind of operations that you can do with them. So it's important to know not just the differences between continuous count, ordinal, and nominal, but to also recognize that even within continuous, you have differences in the variables. All right, so this is a pop quiz for you. So what kind of variables is this? Cars on the road. Will you say that is interval, ratio, count, ordinal, nominal, or unstructured? You can type your answer in the chat. Okay, great. All right, good. So that is a count. You're correct. What of this? The temperature. No, you have to choose from the options that are on the screen. Okay, I'm seeing a lot of ratios and I'm seeing a lot of intervals. So remember that a ratio ends with O, which you can think of as 0. That means that with the ratio, you cannot have negative values. But can you see negative values right on the screen here? So yeah, you can see temperature is -10. That tells you automatically that that's an interval because you cannot have a negative value. There's a ratio has a true 0. And so this is an interval. What of this? Height. Is that a ratio or an interval? Excellent. You guys are getting please, yeah, so this is a ratio. Don't say continuous ratio. It's ratio and interval are both keys of continuous. All right, great. You are getting the hang of this. What of this? The categorizations of race here. So let's say we have American Indians is 1, white is 2, black is 3, Asian is 4, Hispanic is 5. What will you call this variable? I see a lot of ordinal and I see a lot of nominal. See, you should look at the first 3 letters. Ordinal means there is order. That's why we call it ordinal. Nominal means if you fill forms when you're traveling by air, you see they ask you, they translate the forms in English and French. And so you see sometimes they say nom. Nom means name, right? So that means that in a nominal variable, it is just in name only, right? Whatever value we assign to that group is just in name. It doesn't really affect its essence deep within it, right? And so here, this is definitely this is nominal because even if we assign American Indians as 1, whites as 2, black as 3, it doesn't really mean that there's a superiority rating or there's an ordering of those categories, right? We could easily have said Hispanic is 1 and Asian is 2 and so on and so forth. So that is nominal. What of this? Poverty level within different classes. Awesome. All right, great. You guys are getting the hang of this. So this is ordinal. What of this? This is just text. Yeah, this is unstructured. And so we need to also know how to analyze unstructured data as well. So we'll talk about that when we're collecting our data. So for now, let's proceed. So how do we visualize data? Now, like I said earlier, we're going to have this session in two sections, right? Section number 1 is you've already collected your data and you want to write your manuscript, right? And you're thinking of how do I present my data in a way that will be visually stimulating. One way to do that is to use secondary axes, right? Secondary axes are good when you have two data points that have very different measures. So here, for example, we have self-reported use, which ranges from 0 to 100%. And then on the other hand, we have cigarette sales, which is billions of sticks, right? And this ranges from 0 to 500 billion. But we want to put that on one graph. And there may be many reasons why you might want to put on one graph. Number one is when you're publishing, of course, space is real estate. So you don't have the space to put multiple graphs. You want to combine those two graphs into one. But then you also want to tell a story. The story here we want to tell is that when we look at the unit sales of cigarettes, we see that there was a decline in sales over time. But then when we also look at self-reported smoking, this is no longer sales, right? So we have two sources of data. One is self-reported, the other is objective. But the story we're trying to say is that looking at both sources of data, they tell us the same thing, that over time, consumption of cigarettes declined over time, right? So we want to tell that story. So again, remember, we're talking about storytelling, right? We want to turn data into something that is visually stimulating, that the user doesn't even have to read the paper. They can see with their eyes and say, wow, I can see that over the past 20 years, there was a significant decline in cigarette smoking. And it doesn't matter what indicator we used, whether we used ever smoking or we used, self-reported current smoking, or we use sales data. All of those three data points tell us the same thing. So when you have that kind of scenario, a very good figure you could use is this secondary axis, right? So that on the one axis, you have, like, let's say percentage, 0 to 100. And then on the other axis, you have the other one, which is like billions of sticks. I've provided this excellent YouTube videos where you can watch to see how you can create each of those charts. So if you need to create that kind of figure, you just they're very short videos. You can watch them and it will show you step-by-step guidance on how you create a figure with secondary axis. The second here is a what we call a tornado chart or a butterfly chart. The butterfly chart is used, I love it a lot, for when you have two different measures you want to compare, right? And so here we're trying to compare the prevalence of current cigarette smoking, and here we're looking at quit ratios, and we're trying to see how those compare across different subgroups, right? Males and females of different ages, right? So this tells you a compelling story because it allows you, the beauty of a butterfly chart is that it allows you to take data points that are quite voluminous and summarize it in a way that just by looking at it, you're like, oh, okay, I see that, wow, the youngest groups obviously have the highest smoking prevalence and have the lowest quit ratios, right? And, consistently we see that, veterans. So we're looking at so many things here, right? We're looking at age, we're looking at veterans, or we're looking at gender, right? If we were to use any other figure, that will almost be so overwhelming for us. But with a butterfly chart, we can say, okay, this part of this, the left-hand side is focusing on cigarette smoking, the right-hand side is focusing on quitting, right? And within both the left and right-hand sides, we have separate bars or separate colors for veterans and non-veterans, right? So this allows us to be able to take huge volumes of data and tell a story in a way that it doesn't feel overwhelming, even though there's a lot of data there, right? Remember that we said earlier that there are three things we want to address when we're telling a story with data. One is to address issues of volume of data, right? You don't want to just throw huge amounts of data at anybody and expect them to read. Find a way of making it concise and interesting for them to read it, and in seconds, get the scope of what you're saying. So again, I have a great YouTube video here for you to watch to see how to create a tornado chart in just a few minutes. So the next is to add standard errors. And this is particularly important when you want to show the precision of the estimate, right? We want to tell a story, but we don't want to tell a misleading story. That's very important. So in research, right, we want to see how precise are these estimates, right? And the way we can tell it is with the error bars, right? With confidence intervals. And so I would recommend that whenever you're using data in which you have a relatively rare outcome, or you have small subgroups, please try and tell a story that is reliable, and do that by including error bars, right? So it's not just about telling how the groups compare. It's also to tell us that, wow, these groups we should take these estimates with a pinch of salt, right? This group has very wide standard errors, and so whatever result is coming from this group should be taken with a pinch of salt. See, so we tell a story, but we also tell it honestly, by allowing the reader to see that certain groups have very wide confidence intervals, or that the estimates are imprecise. So that's how you want to do that. So again, you can watch this YouTube video to see how to set that up. And then the other is the forest plot, right? And this is very good when you're trying to show, things like odds ratios or prevalence ratios that have, you have a point estimate and you have confidence intervals. And also you might want to also put the actual estimates here. This will be very useful when you're doing like a poster presentation at a conference and you have all this huge table with odds ratios or prevalence ratios. Yeah, just putting it as a figure is more visually stimulating. In fact, we could have taken this step further by making all of those ones that are not statistically significant to be hollow, so that the ones that are filled are the ones that are statistically significant, and the ones that are hollow are the ones that are not statistically significant. So that just looking at it at just one glance, the reader knows, wow, okay, I see that, this relationship was significant for so and so variables, but not for so and so variables at just a few glances, right? So that saves the, imagine putting this kind of data as a table. That would be very overwhelming, right? So goes back to our overall objective of analysis, which is we want to simplify things. We want to make it in a way that the reader has so many things they're doing, right? They're busy with their families, their many other things. They don't have time to read million data points, so capturing things like a forest plot like this with confidence intervals and point estimates in one go makes it very easy for the reader to understand. So in a nutshell, here are some 10 rules I have for making sure that you're presenting your data in a way that makes sense. Number one is don't repeat yourself. So if you're writing a manuscript and you've provided the content in the figures already, please do not repeat it again and put it in the table, right? Because the figure is a way of expressing results in of itself. Number two, please avoid using pie charts in manuscript. Pie charts are extremely hard to read, especially when you have differences that are small, right? It is not a very good way to look at differences, absolute differences between estimates. So please do not use pie charts in your manuscript. You can use a bar chart or or a column chart, but please religiously avoid using pie charts as much as you can. Make sure that all axes are labeled. So don't be that author who submits a figure without, okay, so what is this axis? Like, is this, what exactly is on this axis? We don't know. So make sure your axes are clearly labeled. Ensure that your tables and figures should be able to stand alone, right? Remember that when you read paper, so if you go to, let's say, let me go to PubMed, for example, and let's look at why it's very important for you to have tables that are standalone. So let's say, let me look for a paper here. I'm looking for something that has a figure. No. Aha. So in modern journals, right, it's possible for your paper to be detached alone and for the reader to be viewing it just by itself. So you see this paper in JAMA, I see figure 1, mean percentage of time eligible participants mean percentage of time eligible participants remain up to date with hepatocellular carcinoma screening by year since hepatitis C virus cure, right? I know that the error bars denote standard deviations. The labels are clearly labeled. See, this is from 0 to 100. The horizontal axis is also very clearly labeled. I know that this is time since HCV cure, right? So everything is clearly indicated. So this is what we mean by saying, let your tables and figures be able to stand alone. Like at this point, this figure is detached from the rest of the manuscript, but I can still get a sense of what it's saying, right? It stands alone because just by looking at this, even if I don't have to go back and read the paper, I have a clear sense of what this paper is saying because the axes are well labeled, both the X and Y axis, right? There is a clear figure, caption of the manuscript of the figure, and everything is well explained. So that is what we mean by your content should be able to stand alone. And then tables and figures should be able to stand alone and should contain elements of person, place, and time. Unfortunately, that's not something I see a lot. The title of your table or your figure must contain elements of person, place, and time, right? Now, what does that mean? Let's go back to that figure. Let's look at a good example. MMWR is one of the best journals that just enforces this. So let's look at let's just pick a random table or figure from MMWR, and you can be sure that every single table there has elements of person, place, and time. They enforce it. There's no way you publish an MMWR that the journal editors don't enforce that. Let me find the table here. Okay, let's see. Can you see the screen, Lungile? Or
Yes,
anybody?
doctor.
Okay, already. So this is table. Annual rate of firearm injury-related emergency medical service encounters per 100% emergency medical service encounters by patient and county level characteristics. 858 U.S. counties, January 2019 to September 2023, right? Person, person, the description here, place, and time, clearly indicated. Now let's look for another one. Let's say MMWR smoking. This is the best journal in the world that just enforces that rule, that it's impossible for you to publish something in the MMWR that will not have this compliance with elements of person, place, and time. It's a rule. So trends and differences in prevalence of chronic obstructive pulmonary disease among adults aged 18 years or older by socio-demographic characteristics, behavioral risk factor surveillance system, United States, 2011, 2021, right? Person, place, and time. At the very minimum, your caption must have those three elements: person, place, and time. So if it doesn't have it, it's not complete, right? And if I have the journal editor, of course, you have to go and revise that extensively. So tables and figures should be able to stand alone and must contain elements of person, place, and time. You want to allow for clean white space, right? The figure is not where you want to crowd all the information into the figure, right? Again, I go back to MMWR. Again, it's not as if I have any particular thing with MMWR, but they do it so well that I think is a gold standard for us to look at. You see how the MMWR creates figures? You're not allowed to put any single estimate inside the figure. Apart from the labels and the X and Y axis, right? This is just a perfect model for us to follow. You don't overcrowd. Some people will just want to pack all the information in the world and dump it into the figure. And so they will put in numbers here, 50%. Like, dude, this is supposed to simplify the data. Remember, we said the goal of analysis, especially visualization, is to take a huge volume of data I'm making a small amount of data, right? By trying to put data points every single place, you have completely failed in that objective, right? You have not simplified data at all. In fact, you're giving all of us a headache trying to read your paper. So please don't do that, right? The goal is data reduction, data simplification. So make sure that your x-axis and y-axis are labeled clearly. Now, this is another very good practice. Make sure your axis actually run from 0 to 100. You see this? 0 to 100. Now, sometimes your data points may be such that if you actually made the axis run from 0 to 100, the figure will look so small. So what you can do is that you can surely make it run from 0 to 18 or whatever the value is, but make sure you put truncations. See this symbol here? You should put it. So the scale itself should run from 0 to 100, but you can truncate that axis so that all the readers know that you're not cheating, that we're supposed to understand that this is supposed to run from 0 to 100, but you just want to make sure that the graph didn't come out so small, but you have to make sure that this is there. This is a clear indication that, all right, we have truncated the axis, but it's supposed to run from 0 to 100, right? So this should be a perfect model for all of us to follow, right? And then you see how footnotes are there very copiously, right? If there's need for footnotes, make sure you can put an asterisk and then you put below. Now, when your pattern of asterisk should also follow a pattern, right? There should be consistency in how you use footnotes. So MMWR again, there's a clear pattern in which they use footnotes. You have asterisk, one cross, $1, and one paragraph symbol, right? Then when we're done with that, we start with two asterisks, 2 crosses, and so on. When we're done with that cycle, we'll go to 3 asterisks, 3 crosses, and so on and so forth. So it makes it easier for a reader to just know that, oh, wow, there must be other symbols up there because I clearly see that we are 3 asterisks. Where are the other ones? You don't have to follow exactly what MMWR does, but what I'm saying is that there has to become some consistency in how you report things. Then again, allow for clean white space. Again, this is clearly exemplified by MMWR here. See white space. It's delightful looking at this, So white space is good. Then less is more. The whole point of data analysis is data reduction. So if your analysis ends up being more overwhelming than the original data, then you have failed. So less is more. When you're creating figures for publication, you should aim to have a resolution of 300 dpi, dots per inch, to avoid pixelation. And I'm going to show you how to do that. Be careful about your language. Prevalence is not the same thing as proportion. And there is no such thing as prevalence rate. If there's one thing I hate seeing in papers is this expression, prevalence rate. The prevalence is not a rate, so just say prevalence, right? So mind the language you use when you're describing things. So prevalence of chronic obstructive pulmonary disease. Why is it prevalence? Because prevalence ranges from 0 to 100. A proportion ranges from 0 to 1. Sometimes people use those terms interchangeably, but they're very different. So you need to mind your language. If you want to say prevalence, say prevalence. If you want to say proportion, say proportion. Please don't say prevalence rate. Such a thing does not even exist. And then use color wisely. Again, a figure is not a place for you to show how sure, we want creativity, but it shouldn't be so creative. You shouldn't be so creative at the same time, right? So you want to be careful of safe colors. Some colors do not look so well on the web, right? You also want to make sure there's contrast, especially if you're trying to compare two things. Like here, I would rather have a scenario where they are trying to compare these 4 groups. But instead of using 4 different colors, we use 4 different types of lines, like a solid line, a broken line, a dotted line, and these intermittent lines with dots. It's easier to communicate with this kind of style than have different colors that may appear very similar. And then the user is just confused, like, okay. So again, even in terms of color choice, less is more. Don't overwhelm the reader with so many colors. Just be prudent in your use of color, so that it's easier to communicate. And then rule number 10 is data cannot speak for itself, so you want to provide context for whatever you do. All right, I'm going to stop here and take questions. Bringa, you said there were questions, right? Oh, before I move on, I remember point number 7, I said aim for a resolution of 300 dpi. One of the best apps I know of that does that for you is iFanView. So sometimes journals have very specific requirements. They may say, please send us your figures at 400 dpi or 350 dpi. They are very specific. So with iFanView, let's say you created a figure in, you use Excel to create a figure. So what you would do is, sure, create your figure in Excel, take it from Excel and bring it to PowerPoint and create just one slide, export that figure as PDF, and then import it into iFanView, and then specify, okay, I want 350 dpi, and the figure and the platform will output that desired resolution for you in whatever format you want. So I use it a lot for my work. So I recommend it a lot. So let's take questions. Lunga, you said there were questions. Let me take them now before we move on to the second part. So far we've just covered you have data already and you want to visualize it. So those are considerations. The second part of our session will look at, okay, I want to collect data and I want to visualize it. So what things should I keep in mind? All right, questions, please.
All right. Regarding count variables, how do we make sense of a mean of 4.5, yet we say the account's like 3, 4, 5? Thank you so much.
Oh, okay, I see your point. You're confused by decimal. I mean, if it's averages, right? So it's the same thing as when we say the prevalence of smoking is 19.6. So what we mean is that 19.6 out of 100 people are smokers. So unfortunately, or coincidentally, that's what happens when you take averages. They'll be bound to be fractions or floats. So, and that's where you as the professional should, when you're conveying to, or you're trying to pass a message to lay people, that's one of the reasons why we say always round percentages when you're trying to convey a message to lay audiences, right? Like if I'm trying to communicate to a policymaker or to the media, and the smoking prevalence is 19.6, of course, I'm not going to tell them the prevalence is 19.6. I'll tell them approximately 20% of people of the population smoke, right? So that's why for outward-facing communication, we never use decimal places. We never use fractions because people will be confused. They're like, what do you mean 19.6 people out of 100 smoke? Where is it 0.6%? So again, scientific communication is quite different from communication to lay audiences. And so you never use decimal places with lay audiences for that reason.
All right. What tool analysis can we use to design those charts?
Sorry, repeat that one more time, please.
What tool analysis can we use to design those charts?
You can use in PowerPoint. All of us videos are in PowerPoint. Sorry, I always confuse Excel. Thank you very much. So all of those things all of these figures, we created them in Excel. So you can use Excel. It doesn't have to be something fancy. You can do all of those things in Excel.
Thanks, Audrey, for that answer as well. How do we truncate these figures? Which softwares can we use to truncate the axes in order to present them running from 0 to 100? Thanks.
You can do everything with all of those things. You can do them in Excel.
Is iFanView free?
Yes. Well, to some extent, right? For some things, it's free. For just changing the resolution, yes, it's free. But for advanced features, obviously, you have to pay.
Good evening, presenter. Please, can you expatiate on, where is this? Oopsie. Okay. More prevalence and proportion.
Okay. Proportion ranges from, the proportion ranges from 0 to 1. A prevalence ranges from 0 to 100. So if I say a prevalence of 50%, that is the same thing as saying the proportion is 0.5. What I cannot say is that the proportion of people who smoked was 50%. That makes no sense because proportion is bounded between 0 and 1. So you can say, now again, for communication, the key priority when doing research should actually be to communicate. You want to communicate clearly so people understand what you're saying. Between proportions and percentages, obviously, percentages are easier to communicate. So as a general rule, you should try and stick with percentages where you can, right? And so because it's kind of confusing saying 0.5 smoked. It's like, okay, like what does that mean? But if you say 50% smoked, it's very clear to everybody what you're saying.
Any other questions? Did I miss any?
We're good?
Donatus, I think Donatus wants to ask. You can unmute yourself, Donatus. Can we use the word percentage in place of prevalence?
Yeah, you can use it, but every prevalence is a percentage, but not every percentage is a prevalence. We can report incidents as percentages. We can report a whole lot of things as percentages. So saying percentage is great, but it's not. If you want to speak in pure specific scientific language and you want to be very, very specific, you should opt for prevalence rather than percentages, because the percentage could be anything, right? It could be incidence, it could be prevalence. So but again, so again, depends on who you're speaking with, right? If you're speaking with a lay audience, I would say go with percentage. So that I would say the percentage of adults who smoked was 50%. Because if I now tell them the prevalence of adults who smoke was 50%, they start asking me, okay, what is prevalence? So for scientific communication, stick with prevalence. For communication with lay audiences, you can use percentage.
Okay, thank you very much.
Okay, sir.
Thank you very much.
Okay,
but I've seen papers where they've used those terms, both the prevalence and the proportions, at the same time. And so you suggest to me that they don't mean the same thing. And when they bring proportion, then I should stay away from using prevalence. So I should just stick to one rule. Is that what you're trying to say?
Yeah, I'm not suggesting to you, I'm telling you that, yeah, the prevalence proportions range from 0 to 1. Percentages range from 0 to 100. Of course, the fact that people use it interchangeably doesn't mean it's correct. And that's why I'm telling you that it's great to mind your language when you're using it. Does that make sense? Okay, I'll assume it does. Any other questions?
Anisit?
Okay, hello.
Okay.
Do you hear me?
Yeah, I can hear you clearly.
Do you hear me? So is there like a suggestion on those charts that you have shown us? This presentation is very helpful and is very needful in what you are doing, like doing this research. So as a doctor is continue encourage us and improving our knowledge, I think he can also prepare one day to help us, showing us in that Excel how we do it.
Okay.
Thank you.
Well noted. So maybe one of these days we'll have a we will have a session where we'll just have Excel, creating like very powerful figures in just Excel, no special software, just Excel. And that's great because everybody has Excel, right? So we can definitely have that session where we look at like really complex and really powerful figures that you can just do in minutes with just Excel. So we can do that. Any other question?
Dr. Asundua.
Good evening. My question is that the time that I wanted to create my Chi-Square account, I created the first day, but subsequently I was not able to access it again so that I can be practicing the competencies that have been sent to the WhatsApp group. So I don't know what can I do to redeem or to recover my Chi-Square account.
Okay,
that's my question. Thank you.
Okay, thank you. That's a good question. We'll address. You can email us. Lungile will drop an emails, so we'll address those or administrative issues some other time or after the session. But yeah, don't worry, we'll take care of it for you. Any other questions?
Yes. What is your view on the use of frequency as against prevalence for a hospital-based study?
Frequency suggests just count, right? Say frequency of, it's a frequency could be anything. Frequency could be count. Frequency could be, it's colloquial language, right? So going back to precision of language, we need a more standard way to express, because frequency could mean rate, frequency could mean count, frequency could mean prevalence, it could mean anything. All of those things are frequencies. So what frequency are you talking about? So we need more, again, precision of language is what science is all about.
Is it therefore ideal to say 0.2 proportion or 20% prevalence?
You should try and stick with percentage, please. Proportions could get very confusing because you could have a prevalence of 0.5 too, right? And then, yeah, so for cleaner language, you should know the difference between a proportion and a percentage. And it's just better to stick to a percentage in expressing because it's clearer that way.
Can Prof. Agaku kindly reshare the screen to such that the yellow screen writings go away? They
I'm not sure
kind of distract.
Yeah. I don't know what happens. I actually don't know the mechanism through which that happens because I think it's somebody else who is making those lines. And I don't know how they make it. But the slide itself doesn't have those things, you see? The slide itself doesn't have. So I think somebody is taking notes, and as they're scribbling, that line is appearing. I'm not sure how, but I've seen it many times on AHA. You see?
So what happens when you Sangodare Adewale?
So I think that, see, AHA.
Sangodare, please refrain from taking notes.
I did tell him to refrain from taking notes.
Dr. Gaku, but can you try to share your screen, to reshare your screen again? And then Sangodare, can you stop taking
so
notes?
My point is that the screen doesn't, the slides themselves do not have.
But what happens when you stop sharing and you share again? That's what they're asking you to do.
Okay. So I should stop sharing and share again.
Yes.
Okay.
Yes, please.
Alrighty. So let me stop sharing and share again.
If you can ask your question in the meantime. You can unmute yourself.
Okay, thank you so much, Doc. Can you please share the link for the plots, the YouTube link? Can it be added to the Chi-Square YouTube channels?
Sure, we can do that. But
Okay.
it's also you're also going to get the slide, so you'll be able to access them. And like we promised, we're going to have a special day where we'll just focus on creating charts in Excel.
Okay.
You'll be
That would
shocked
be
at how much
awesome.
you can get out of Excel.
Wow. Thank you so much.
Oh, you're welcome. Lungile, are we done with all the questions?
No. Kindly explain again how height is a ratio.
So your question, so you should ask yourself, right? Is it possible to have a negative value for that number, right? Remember that ratio ends with 0. Ratio, when we spell it, just think of the O as 0. So that means that a ratio ends at 0. It cannot go below 0. So ask yourself, can I have a negative value of that number? If you can, then that means it's not a ratio.
Is there such a thing as hospital prevalence? I know that strictly speaking, prevalence is an epidemiological term. If there isn't, how do we report results from hospital-based studies?
You simply say prevalence of XYZ in this hospital was XYZ.
Okay. That question was repeated. Okay. Kazim, thank you. Was that Moses? The lines are gone. Thank you. Kazim, you can unmute yourself.
Okay, thank you. My question is that what kind of classification can I give to a set of numbers? A set of numbers 1, 2, 3, like the colors. You say colors can be arbitrarily labeled, but I have colors that have wavelength bands. They have bands.
So if it has bands, so that bands, but you are saying therefore that there's natural ordering.
Yes, there's a natural ordering for my colors. Like for instance, blue is between maybe 400 to 500 nanometer. Then green is between 500 to 600 nanometer. You know its color.
I understand your question. So, but you've already answered the question yourself then. So what do you think is the answer?
Interval.
No, it's categorical, right?
Yes.
So if it's categorical, what do you think it is then?
Because to me, it has an interval.
Even things that have intervals can be categorized. So it depends on whether you're looking at it as a continuous variable or whether it has been categorized. The way you suggested it made it sound like it was existing in categories, but those categories had an inherent order to them. In that case, it will be ordinal, right? Because there's order. The color is just a proxy for the underlying wavelength. So what you're really asking is the categories of wavelength. Is that ordinal or is that nominal? That's actually your question. In that case, it's ordinal. Does that make sense?
Okay. Thank you very much.
So again, anything can be equal. Remember that continuous variables can also suddenly become categorical, right? So don't think of the natural state of a variable. Think of the state in your data set. That is what should be that's what you should be considering. All right, Lungile, any other questions? Are we good?
Okay, I think we have the last one. Okay, I don't know how to pronounce your name, but can you unmute yourself? ESHENSH. You can ask your question.
Okay, hello. Okay.
Hello.
Thank you, Zashensh. Thank you very much for a very lucid presentation. I asked the question about the hospital prevalence, and the reason I asked that is because some people frown at the use of prevalence when you're reporting persons with disease. Remember that persons who come to the hospital already have a disease, one disease or the other. And so they strictly want prevalence used as an epidemiological term. where, it's the number of persons in a population period of time that have a particular type of disease or so. So sometimes I've had to, when I send papers to a journal, there are certain journals that will not report do not accept a hospital prevalence as an epidemiological survey. They would rather say it's a frequency, that's the number of people. It's like just a count. You're not talking about the prevalence. So I would like you to speak to that, because I think you are of the opinion that you can say the prevalence in this hospital, but that is not accepted by many who think prevalence is basically a population-based thing, something like maybe in the community or I hope you understand what
Yeah, I
I'm trying to
understand.
say.
That was very
Excellent.
eloquently expressed. Thank you very much. So epidemiology does not only exist in the population. Epidemiology exists wherever we will it to exist. Epidemiology exists in the clinic, exists in, that's why we have different types of epidemiology, right? Epidemiology is a broad specialty, but we also have specialties within it, like any other specialty. We have occupational epidemiology and, clinical epidemiology and so on and so forth, right? So yes, it's broad. The problem with epidemiology as a specialty is that it's one of those specialties that has just been hijacked by everybody. Someone can have absolutely no training in epidemiology formally and just wake up and declare themselves as an epidemiologist. It is only one of those few specialties, few careers that I have personally seen that happen. Like, wow, like everybody's an epidemiologist. So the problem, however, with that self-designation is that people have no formal training of epidemiologic methods. And so sometimes, we say half knowledge is dangerous. And so people just make very declarative statements that, wow, like this is how this is what this concept is, but to address the core of the issue, no, you can call it prevalence. Prevalence does not mean that it must be in the population. That's why a key element, a key framework in epidemiology is PICOT, PICOTS. P is population. That's why we define our population right at the beginning. We say our population is people who visit this hospital, right? So that whenever we're talking prevalence of XYZ among this population, it's very clearly defined who we are referring to. So no, population prevalence could refer to, it doesn't have to be the population, it can be, in this case, they're referring to population to mean the general population. But anything can be population based on how we define it, right? So, but at the end of the day, you want to get published. So if you want to get published in that journal, you just have to do what the culture is there, right? So it's not a must that you must say prevalence if they are so against prevalence. So you can say the percentage of people in the hospital who reported XYZ was this. The most important thing is that you have been able to communicate what your findings are, right? So the issue is not whether it's a bigger population. So that's the take-home message I want to really enforce or reinforce, right? Population is whatever population we have defined it to be. I can do a survey of the people here in this room now and say the prevalence of exam failure among this studied population was XYZ, right? Because I have defined the population as people who attended this Zoom call at this point in time. That is the population. So population doesn't have to be the population of Nigeria or the population of South Africa or the United States. If I am defining it that way, well, that is that population. But population is whatever we are studying. It doesn't have to be the bigger population. So I hope that distinction is clear. But again, like I said, if you have to stick with the terminology in your journal, well, but epidemiologically, that is not true at all. Any other questions? Lonely, we're good?
We are good. Let me see. Yeah, we are
Okay.
good. I'm about to share the evaluation survey in case our sessions are usually long. So some people leave while the session continues. So please complete the feedback survey before you leave. We also need your names and email addresses for your certificates. So please complete that information as well. Thanks, Dr. Agaku. You can continue.
Okay. So the second part of our study is how do you design when you're designing your survey? So we've covered the first part, which was you already have the data collected and you just want to visualize it. But now it's like, now I just want to collect data and I want to make sure the data is rich and that I can communicate in a way that makes sense. So the point here is that you want to make sure that you give a lot of thought to the kind of questions you're capturing, right? They said variety is the spice of life. We said at the beginning of our class that one of the three things you want to address is the mundane. You want to present old information in new ways, right? So in my questionnaire here, I've added a whole lot of questions that address things in various new ways. So what I'm going to do now is I'm going to upload this questionnaire and we'll take it the next 2 minutes. And then you can see how kind of visualizations I can create with my data that tell a story, allow me to tell a compelling story. So let me upload this questionnaire into the Chi-Square platform. And let's just take a second to complete it together so that you can see the kind of visualization I can create in a moment's notice. So let me create that survey right now and let's proceed with that. So let me open my account. I'll start a new survey. So for those of you not familiar with the Chi-Square platform, it's a research platform. It's a one-stop shop for everything that is related to research. So let's create a new survey here. This is so the title again, let's put elements of person, place, and time among workshop participants. (2021), right? Online, just to reinforce the ideas of person, place, and time. Online as a place, persons, workshop participants. Oh, 2024. My gosh, I'm living the past. The location, let's leave that blank. The aims, you can type the aims yourself, or you can have the platform suggest aims for you. So let's have the Chi-Square platform to suggest aims for us for our study. So these are some of the aims that's suggested, which we can choose to use. Let's select that one and let's clear the remaining ones. So we can edit that to evaluate the perceptions and experiences of individuals working in the tech industry, blah, blah, blah. Keywords, let's just say tech, and let's create this new project. You can invite collaborators, but I'm going to skip that for now. And let me just upload that questionnaire, that Word document. I'll import the questionnaire from Word. Okay, the questionnaire has been uploaded. So let's quickly just make sure that the questions are, there are no flags with our survey. Let me quickly preview the survey to make sure there are no flags, and then we can quickly take the survey. Okay, this looks good. Okay. Yeah, I think my demo has timed out. Let me start a new demo. The demo times out for a shot. That is so funny. I'm reading the chats on the. Let me check that question. There's something wrong with that. Okay. Let me set a timeline. launch today and so we can see when we collect data in real time, how we can also make sure that we can visualize it in a way that makes sense. Let me launch this quickly. And share the survey, but let me take it quickly first to make sure everything is kosher. So yes, oops. Next. Now let me select this. C++, Java, and Python. Let me, you guys are so funny. I'm looking at your comments in the chat and that's cracking me up. Okay. Actually had, sorry, before I take the survey, let me make some quick edits. I should have made these questions to be, I have some open value questions there that I want to make sure I don't collect rubbish or nonsense. So let me make sure they are, I restrict them so that I only allow only numbers. The minimum should be 0. So I don't get negative values. Let me update that. The same thing with the other. Allow only numbers. Okay. All right, let me resume my survey. So please, let's take the survey now and let's see. Yeah, I paused the survey to make some changes. That's why I said paused. But you can take the survey now, please. So let me take another. So yes. So for today, you guys are all working in tech. Yo, man, oh, I ended up, sorry, you guys must pardon me. For some questions, there were even words, like this question says, if we were to describe the work culture at this with just one word, what would that be? I mistakenly specified to only enter numbers. So you can just keep that question. This is why you have to review your questionnaires very carefully. But the goal, the point here is not to design questionnaires per se. So let's just, in the spirit of that, just proceed. Let me look at the responses we have. Oh, we have a lot of responses. So we can download this methodology report to see how the study was conducted, because you need the methodology report if you're going to write a manuscript or a report. So the platform writes that for you. So let's look at our report. So working in tech survey, this is an overview of our study design, the background, the participants, we had 17 individuals, and where they came from, survey administration, questionnaire, and the limitations of the study. All right, so we can use that for a report or whatever it is we want to do with it. But let's look at the code book. It's very important that when you have data, you don't just rush into the analysis of the data, that you take time to understand what the data is all about. That should take priority over just analyzing the data, because you might be analyzing noise. So it's great to come here and download the data set. On the Chi-Squares platform, you get data, both the raw data set, and the platform also cleans your data set for you automatically. So if you access the clean data set, it's already clean and ready for analysis. Obviously, for you to understand the clean data set, you need a code book. So let's look at the clean data set. Let's look at what it looks like. So those are things you want to do before you start analysis. So please do not just jump into analyzing data when you have not reviewed the data and you have looked at the amount of missing values and so on and so forth, right? That is extremely important. On the Chi-Squares platform, every individual has a data quality score. So you should always review the quality of the data with the data quality score. The data quality score, to know what its values are, you have to look at the code book. So let's look at our code book to inspect our data quality before we even do the analysis. So download code book. And next week, we're going to do more detailed review of how to look for all of these things before we start. But this is just a preview for next week. So let's look at the code book. So this is our code book. So this is the data quality score. And the data quality score on the platform is calculated from 4 parameters, whether the individual is a duplicate, and we look at duplicates based on, things like device signature, like your IP address, looks at like the device and browser signatures, both of those, and then the pattern of responses. It looks also at straight lining, which is just answering the same thing, AAA, consistently. It looks at large volume missingness, and it looks at speeders. If you just pair through the survey, the platform knows that, okay, this is the expected time on average, given the number of questions and looking at the statistical distributions, that somebody should have answered this question. And so it flags issues here. So data quality score, most people have 11. You see that? And what does 11 mean? 11 means there are 3 issues identified as a problem. There were suspected duplicates. Maybe there were many people who did the survey. Well, I did it many times too. There is large volume missingness. So some people skipped next without answering the question. And straight lining, just putting the same value, AAA, consistently. So we have a lot of 11s. We have 5. 5 means, again, suspected duplicates and straight lining. So you assess the quality of the data first, and then look at the patterns of missing values. If people have missing values, why do they have missing values? For every variable that has missing values, there is a corresponding indicator for missingness that tells you the type of missingness it is, right? So if you look at this column, for example, this is the variable here, and this is the missing value for that variable, the indicator for that variable. So you have P. P means partial complete. It means that they never got to that question, and then they left the survey. You have P there, you have, and for this individual too. N means non-response. The person got to that question, and then they chose not to answer that question by skipping to the next one. So the platform captures all of those patterns of non-response for you so that you can evaluate the quality of the data you have received. You also have the date and timestamp for each respondent, right? So you have all of those things that are great for you to evaluate before you even jump into analyzing the data. To look at a descriptive analysis of the data, you click on the analysis report and choose on whether you want to analyze for the whole population or for a subset of the population, right? And so that will allow you to see what kind of visualizations we should put. But like I said earlier, right, before you even start analyzing your data, spend a lot of time with this, right? Try to understand the data clearly so that you will be able to understand, okay, what kinds of things should I do, right? This particular respondent has a lot of missing values. So what should I do, right? So that should inform the way you analyze the data and how you want to proceed with your analysis, right? And then you have the raw data set, which you can download. The raw data set is a bit different from the clean data set. So if you see the values here are, neither agree or disagree, and in text, whereas the clean data set has those as codes, right? And you can understand what those codes are by looking at the code book. The code book tells you what each particular response is. So, one, for example, means software engineer, and 2 means data scientist, and so on and so forth, right? So that way you can understand what each of those means. We are over time now, so we're going to next week we're going to pick up from how do you inspect the data, how do you create visualize. So you've collected your data, how do you inspect the data, how do you create visualization, and then how does that determine or influence the kinds of analysis you can do subsequently. So that's what we're going to cover next week, Friday. So I'm going to stop there and see if there are any other questions that were asked, Lungile, and I'll take them.
Not yet. Let me
Okay.
see. Any other questions? How do we deal with unstructured data like clinical notes in order to collect meaningful data?
Oh, that will be covered next week extensively. But you can apply, in general, you apply methods. That's qualitative data, unstructured data. So there are different ways to analyze that, which we'll cover next week.
Okay. Any other questions? Are there any sessions that show how to use the Chi-Square platform?
Yeah, we have sessions on Thursdays and that cover specific things. So so you can definitely join our sessions. And you can also, the platform also has, if you have questions, you can ask them of our AI. So for example, if we have quick question here, so if you're stuck on something, you click on quick question and just ask the AI. For example, you can ask it, how do I set up a new survey on the Chi-Square platform? All right. And it will give you a response that, and so here it says you can access a demo video for setting up the Chi-Square, a survey on the Chi-Square platform by clicking on the link provided. So let's see. Let me see what video that is. Welcome to Chi-Squares. So you see, so yeah, it's absolutely correct. So you can any question at all. You can say, I don't know, any question at all you want to ask. You can ask the AI, and it will tell you how to guide you on what to do. So in between our classes, you can also ask the AI questions that you have.
The inclusion of person, place, and time in table titles, is it peculiar to epidemiological data?
It's a best practice for any kind of research, but obviously not every research has persons, right, or populations in that kind of context. If you're doing research on nanoparticles, that may not apply. But as far as population research is concerned, I believe most of us here do population-based research. So in that case, yes, regardless of whether your field is, sickle cell research or whatever the subject matter, it doesn't really apply so much. But that's a good practice to abide by.
How can we calculate sample size using p-value, confidence intervals, and power for a study which is a sub-study of a main study?
You have a study which is a sub-study of the main study. Mm-hmm. Why do you want to do a sub-study of a main study? So that, first of all, let's answer that part.
Jisu, are you still here?
Remember that the sample size for the main study was done to assess the differences for that study. So by doing a sub-study already, you're no longer powered to detect any differences. if that first original study was calculated to detect differences, the same differences that you are trying to detect. That already means you're not powered already. So that's why I'm asking you, why do you want to do a sub-study of the original study?
Recorded version. Noni, I shared the YouTube link and I tagged you. We are live on YouTube, so you'll be able to watch the session again on YouTube. I'll share that link again. Shall we have sessions for advanced data analytical methods? That's a request, Dr. Agaku.
Oh, okay, sure. We can definitely put that in the agenda.
Is it possible to do the mixed research method study without conducting interviews at PhD level?
So when you say mixed, what are the 2 things or 3 things being mixed then? Because generally when we say mixed method, methods. Sorry, go ahead. Sorry, I'm interrupting you.
No, I'm sorry. Motepane, I wanted to say you can speak if you'd like to. But Dr. Gaki, you can continue.
No, in general, when we say mixed methods, right? That could mean anything. Anything could be mixed. So are you mixing geographic GIS methodology with population level methodology? Are you mixing qualitative with traditional quantitative? Like anything can be mixed. So mixed method doesn't mean one specific thing. Yes, go ahead, please.
Who's that? Who's speaking?
So anyway, bottom line, without much more context, it's impossible to answer that question because if we don't know what is being mixed, then we don't know. It could well be that what is being mixed does not require interviews. We don't know. So the question is unanswerable.
Both quantitative and qualitative research.
Okay, so how do you want to do it? Now, qualitative research could be different things too, right? It could, so it depends on the context. It depends. Are you trying to do a qualitative research where you are looking at analyzing data from blog posts, for example, across a topic? Well, in that case, all you have to do is do data mining and qualitative interpretation of that qualitative data, right? But if your data involves semi-structured interviews of key informants, then I fail to see how you pull that off without actually interviewing them, if the goal is to interview them. So no, if you set out to do a mixed method which involves qualitative components or a qualitative component, then it's kind of hard to evade that, right? Because that is the very thing you set out to do.
Ify?
Okay, thank you, Doc. Yeah, please don't mind. My background is quite noisy. I want to ask if you have collected data not with chi-square, now you want to just use chi-square to analyze your data. Is it possible?
I've had that request so many times. I've said I'm going to solve that problem once and for all. So just give me a few days. I will solve that problem. Yes. I've had that question too many times, so I've said that I'll address that problem. So yeah, it's going to be possible. Everything is possible, by the way. It's just whether we want to do it or not. As far as it involves writing code, wow, everything is possible. Yeah, we can definitely have modeling on infectious diseases. There are specific models for infectious diseases. And so yeah, we could definitely can I respond to emails? Unfortunately, no, I don't have time to respond to emails because I can imagine I'm overwhelmed. I cannot respond to emails. It's impossible. If I were to respond to emails, I would never do any work. But your emails will be responded to. Let me quickly add that. Someone will definitely respond to your email. It may not just be me. All right, any other questions?
I've just shared the link to the feedback survey again. Please respond if you haven't yet.